Hi to everyone, my name is Jackie. My number chemistry is D180033. Now I will present about the introductions. Recycle and use convolutional neural networks for the material classifications. One of the most effective method that can be used to dispose of waste is to use the image processing method. This method uses a system called the convolutional neural network (CNN) to observe and analyze the visual image of the solid waste, example like the bottle and the aluminum cans. CNN method is used to investigate the input image and divide the visual image into the many different categories. The CNN methods can be distinguished by wide hair and depth. CNN method also consists of variety layer of the convolutions and polyline layer, completely linked layer, and the layer of the normalizations. The classifications of the recycled material can prevent the pollutions and save the money and save the energy and reduce the greenhouse gas emissions and reduce the amount of the waste and maximize the use of the products. The methodology, we use the Google Colab. The Colab allow anybody to write and execute the Python code through the browser. The browser like Google Chrome's browser, and especially well suited to machine learning, data analysis, and educations. Next, CNN convolutional neural network, and we can call it the connect, and have a deep fixed architecture and impressing potentials to generalize faster than the network of the entirely linked structure. And the multi-layers precisions typically means a network they are completely connected. That means that every neuron in one layer is connected to all neurons in the next layer. This network fully connectedness means it is likely to bypass the result. And when a CNN is presented, a filter of the connect may be used on the input data, and compared to the other image recognition algorithms, CNN use a processing. The most positive feature of the CNN is to reduce the number of the parameters in the artificial neural networks. Next, VGG. VGG is an innovative object recognition model that supports out to 19 layers. US deep CNN VGG also outperforms the baseline on many tasks and the data sets outside of the ImageNet. VGG is now still one of the most used image recognition architecture. And next, DenseNet. And DenseNet is a type of the convolutional neural network that's utilize dense connections between the layer through the dense block, and where we connect all layer, we matching the features of map size directly with each other.
Hello, good day, doctor. My name is Kelvin Cheng. My matrix number is AE180101. So today I'm going to explain the assignment tool. So this is the demonstration of the assignment tool. So first step, we need to connect to the drive. So this is the drive direction. And next, we need to feed the dataset directory. So this is the link or the directory where we get our image. So the third one is create train and validation data directory. So we separate in two parts. One is the train directory, one is the validation directory. For test directory is what we capture before. So this is the image we capture. So first is the can and the bottle is in the same direction, and the second is the can stand at the original position, and the bottle at the back position, and the third one is opposite with the image tool. So now we're back to our Google Colab. So okay, we run it first. Okay, it is successfully. So for step 2, so step 2 still successfully. Next for step 3, also successfully. So we'll import for the TensorFlow. Next, we will use the CNN model. So, this uh, this parameter we have tried many times. So this is the best parameter we use for this assignment task 1. So it's already success. So now we pre-process the input data. So it's already successful. So that we can found that the 466 image is belong to 2 class and the 210 image belong to 2 class. Now we start the training process. So the step for approach is 20, approach is 50, and the step is 3. So now we run it. Okay, so it's already complete for the step 6, which is the training process. So now we get the plot of the outcome. So that we can see that the both of the result is the accuracy is higher than the verification loss. So that means that our training is still very accuracy. Next is assignment task 2. So for task 2, we are going using the 2 different methods to get our result. So first, we also do the same thing, connect to the Google Drive and also feed the dataset directory. So this step is same with just now. And also we create the train and validation data directory. So now we using the pretend model with DenseNet. So DenseNet is for this task. So now we run it. So it's already complete. So now continue with the model. Okay, now we pre-process to the input data. So it will classify the class. So okay, so it found the 466 image is belong to the 2 class and 210 image is belong to the 2 class is same with just now. Now we start the training process. So the step per approach is 20 and then the approach is 15 and the step is 3 is also same with just now for the CNN. Now we run it. Okay, so it's complete already. So now we try to plot out the outcome. Okay, so this is the outcome. We can see that all of the result is almost getting the 1, and the validation loss is very low. So it means that our accuracy is very high by using the DenseNet. Next, the task 2, I'm using the VGG16 as the pre-train. So using the almost same method for connecting to Google Drive, fit the dataset directory, and create the train and validation data directory. Okay, next import the TensorFlow. So next is construct the pretend model for the VGG. So below that is the pretend for the VGG. So there's the result. So for the model is the crosstalk module sequential. Next for the pre-processed input data. Now we run it. Okay, now we already done. So it will classify in 2 class. So next is the training process. So the approach and step for approach and also the step is 20, 15, and 3. So now we wait the approach complete first. Okay, so it's done. Now we plot the outcome so that we can see the accuracy is quite a bit low compared with the DenseNet. So now we look at the result of the DenseNet. So this is the result of the DenseNet. So the DenseNet having the higher accuracy and the low training loss compared with the VGG. You can see that the VGG accuracy is uh, quite low for a lot of the data is very low for accuracy. So that's all for the demonstration part and also the result. Thank you.
Okay, now we continue about the conclusion for this assignment. CNN, VGG, and DenseNet are the convolutional neural network commonly used for an image classification task. Managed to build the CNN model and fine-tune for it, able to analyze each other model performance in the first convolutional layer, middle convolutional layer, and third convolutional layer. DenseNet model are less complex than the other while having less currency. And the last VGG system are more complex as a model but able to provide high currency. That's all for me. Thank you.